A linear transformation T is defined as T maps the point xy onto x plus 2y, 3x minus y. Find the invariant point under the transformation T. B. The point whose image is 3, 2 under the transformation T. We take solution. The invariant point under a transformation is simply that point which remains unchanged after transformation. That means the point is mapped onto itself. Transformation, we have T that maps xy, point xy onto x plus 2y, 3x minus y. For question A, we are going to start by saying let A, B, this point, to be invariant point of the transformation T. That is, it simply means if we take the point AB under this transformation T, the point AB will be mapped onto itself, AB. The transformation of the point AB gives us, applying this, what we have at the right hand side, xy goes to x plus 2y, 3x minus y. We are going to replace x with a and y with b. This will give us a plus 2b, 3a minus b. It simply means a plus 2b, 3a minus b will be equal to ab, since it is mapped onto itself. A plus 2b, 3a minus b is equal to AB. Then this will give us a plus 2b to be equal to a. The x coordinates will be equal. A plus 2b will be equal to a, and the y coordinates will be equal 3a minus b will be equal to b. Then if we transfer a to the right hand side becomes negative, this will give us 2b to be equal to a minus a. Transferring b to the right hand side becomes positive, this will give us 3a to be equal to b plus b. Then 2b will be equal to a minus a, which is 0, and 3a will be equal to 2b. This will imply that if we divide both sides by 2, 2b divided by 2 is equal to 0 divided by 2. Here, if we divide both sides by 3, 3a divided by 3 is equal to 2b divided by 3. Then b will be equal to 0. 0 divided by 2 gives 0. 3 will strike off 3. Our a will be equal to 2 times b. 2 times 0 gives us 0 divided by 3, 0. A is equal to 0 and b is equal to 0. The invariant point of the transformation T is 0, 0. That means this point remains unchanged after undergoing the transformation t. We move now to question B. For question B, we have to find a point whose image is 3, 2 under t. For B, we are going to let the xy to be point with image 3, 2 under the transformation t. It simply means if we take the point xy, take it under the transformation t, such, then the image, which is x plus 2y, comma 3x minus y, should be equal to the point 3, 2. For these 2 points to be equal, then their x coordinates must be equal and their y coordinates must be equal. That is, x plus 2y must be equal to 3 and 3x minus y must be equal to 2. This gives us a pair of simultaneous linear equations for which we have to solve for x and y. We are going to solve the pair of simultaneous linear equations by making use of the method of substitution. We call this one equation 1, call this one equation 2. In equation 1, we are going to make x the subject of formula. X plus 2y is equal to 3. Then x will simply be equal to 3. We are going to transfer 2y to the right hand side. 3 minus 2y. We call this one equation 3. Next step, we are going to put equation 3 into equation 2, which has not been used. That means in equation 2, anywhere we see x, we have to replace x with 3 minus 2y. This will give us 3 times 3 minus 2y minus y is equal to 2. Expanding this bracket, this will give us 3 times 3, 9. 3 times negative 2y gives us negative 6y minus y is equal to 2. This will give us 9. Negative 6y minus y gives us negative 7y is equal to 2. Next step, we are going to transfer 9 to the right hand side, which becomes negative. This will give us negative 7y is equal to 2 minus 9. This will give us negative 7y to be equal to 2 minus 9, which is negative 7. Next step, we are going to divide both sides by negative 7 so that we can get y. Dividing both sides by negative 7, this will give us negative 7y divided by negative 7 is equal to negative 7 divided by negative 7. At the left hand side, negative 7 will strike off negative 7, we'll be left with y. Then y will be equal to, at the right hand side, negative 7 divided by negative 7 gives us positive 1. Therefore, y is equal to 1. Next, we are going to put y equal to 1 into equation 3. Remember, in equation 3, we made x the subject of formula, i.e. that is x is equal to 3 minus 2y. we are going to replace y with 1. This will be equal to 3 minus 2 times 1, which gives 2. 3 minus 2 gives us 1. This is the value of x. The point xy, of which x is 1, comma y is 1, has image 3, 2 under the transformation t. It simply means under the transformation t, the point 1, 1 is mapped onto the point 3, 2. Let's verify this and see. The transformation of the point 1, 1 maps onto, this is the transformation t. It assigns xy to x plus 2y, 3x minus y. We are going to replace x with 1, y with 1. This will give us 1 plus 2 times 1 for the x coordinate, 3 times 1 minus 1 for the y coordinate. And this will simply be equal to 1 plus 2 times 1 gives 2. This will give us 1 plus 2, comma, 3 times 1 gives 3 minus 1, which is simply equal to 1 plus 2 gives 3, comma, 3 minus 1 gives 2. You can see the point 1, 1 is mapped onto 3, 2 by the transformation t. Therefore, the point with image 3, 2 is the point 1, 1. We are done with the solution of this question. If in case you have any worries, feel free to drop your questions at the comment section. Please you like the video, share and subscribe to this channel. Thank you very much for watching.